All right, lesson 8.1, average value of a function on an interval. Average value, what is average value? So yes, we're skipping when it comes to the last two chapters, the last two units. I always just go from 6 to 8 and then maybe come back to 7 because 6 and 8 are related. What's an average value? What is an average value? The average height of the function f of x will equal to the area under the curve divided by the width of the integral. The average value is the average height of the function f of x. The average height of the function f of x will be equal to the area under the curve divided by the width of the integral. So you're like, what does this all mean? Average value of a continuous function f over an interval including a to b is average value, so the formula is this, 1 over b minus a integral a to b of f of x dx. The average value of a function over an interval involves a definite integral. Definite means that it has bounds, upper and lower bounds, a and b. Wow. You got to really deeply understand this. Yeah, we're getting into something now. They're like, wow, this is a lot to really. There's this proof here that I typed up. So we have an integral from a to b of f of x dx. So this right here is just the fundamental theorem of calculus, no, part 1, where we had is it part 1 or is it part 2? It's part 2, whichever one it is. You guys remember we had said something about the area under a curve. Okay, so you have this. Let me remind you what it was. It was the proof. No, the integral from a to b of some function f of x dx is equal to some f of b minus some capital F of a. That's what we had before, where this is the antiderivative function. See, antiderivative, that's what we had. Antiderivative of this lowercase f. Antiderivative evaluated from a to b, and really that's what this is, where we have this is the antiderivative g and is the antiderivative of f. This is a true statement. This is just a fundamental theorem of calculus. Given that, going back to chapter 5.1, unit 5.1, given that all the mean value theorem conditions are met, then we can say that this is true. The mean value theorem says that for some function, and let's think about it, for what we've done is that let's say G is some position function. Well, it was something about, the mean value theorem was something about the average rate of change. On an interval. In an interval from A to B. Is equal to this here, this is this average rate of change on an interval from A to B is equal to what? Who remembers what it was? What did I say was the mean value theorem? If I go from here to the coast, I go on this weekend, I went to what is that? What's your favorite place to go? Pismo? Is it Pismo? Morro Bay somewhere? So my average velocity, it was 2 miles, 70 miles per hour. That was my average velocity when I drove from here to Pismo Beach. I did not go 70 miles per hour the whole time. I didn't put it on cruise control. I was 55, then maybe I speeded up to 90, didn't get a ticket. No, I didn't do that. But anyways, my average was 70 miles per hour, no? At some point, I was, at least one time, I was going exactly 70 miles per hour. I had to have, at least one time, I was going exactly 70 miles per hour. And so it's saying that G of B minus G of A, B minus A, is equal to G prime at some critical number point there that was true, that I was going there. All right. So now, well. What are we gonna do? What if we take the derivative of this thing? What was it if we took the derivative of this? If we take the derivative of this, see what we're going to do to this one here? No, we're not going to take the derivative of this. What I'm going to do here is for this statement here on the left, why don't we divide it by B minus A, then we divide this by B minus A. I don't know. G of B minus G of A over B minus A is this, which this is equal to this, which has to equal to this. So G prime of C is equal to the integral from A to B of f of x dx divided by B minus A. I don't know. You believe it? Sure. You're like, it logically makes sense what I just said. It's true. It's that the average value is equal to G prime of C. Okay, sure. Which is G prime of C is equal to F of C. At some point. So now we go to this is equal to this because yes, G prime of C is equal to F of C. That is true. That is true. So, all right, let's move on from this. So we have that this is an average value. The average value is equal to G prime of C, where G prime of C is equal to F of C. Let's do some problems based off of this. But let's just remember what they are. This is the average rate of change of the antiderivative of F evaluated from A to B, which is equal to the average height of F of X. So the average height of F of X is equal to average rate of change of G of X, which is the antiderivative of F. This is a good thing to just kind of remember this statement right here. The average rate of change of G of X is equal to the average height of F of X. Here we go. Let's do some problems now. Find the average value of the function F of X equal x squared plus 2 over the interval from 0 to 3. Well, if we just go off of the formula, no? Go ahead and write it down. If we go off of the formula, it's pretty straightforward of using the formula. All right, you got a lot of time here. All right, so find the average value of the function there over the interval from 0 to 3. This is what it's saying. Don't copy this down because I already have it on the web on my presentation here. This is what it's saying. You have some function f that is x squared plus 2. So it's just a quadratic shifted up 2. So there, this is the function. Don't write it. I already have it. Just pay attention. F of x. This is f of x is x squared plus 2. So it's saying that the area under this from 0 to 3, 1, 2, 3, this is the area under it. Okay? So there is some height here. There's some height where all this area can fit perfectly in a rectangle that would fit. What height? Imagine that it's like it can fill into something like it's water. What height would it be of a rectangle where it would fit it? See, that's already a little too high. Maybe here. What I'm saying here is we have this rectangle here, this thing, that this piece will fill into here, and it fill out perfectly this rectangle. And what is this height of this thing? Understood? Yeah, what I'm saying here? That's what it's saying. What would be the height where this can fill out perfectly into this rectangle here? Well, that's the question, and the answer is just this. What was it? 1 over what? 1 over, was it b minus a? 1 over b minus a integral. Well, I want to write it down like this, but it's actually divided by right here, but I just factor it out from a to b of f of x dx. Well, we know what a and b are because it's given to us. Well, that's the formula, no? Let's go. Average value. So it's going to equal to 1 over. This is A, this is B. So what is B minus A? Look at the numbers. What's B minus A? 3. Just 3, no? 1/3? Yes? Integral from 0 to 3. What's the function? x squared plus 2 dx. Ah, that's an easy integral. See, now I'm giving you very easy integrals here. Just let's integrate this and evaluate it. So it's going to be, the integral of x squared is going to be what? X to the what? Third over what? Over 3 plus what? 2x. Yes. Let's have it, let me do this. The algebra is the problem. Let's put this 1/2. Oh, no, it's not one, it's 1/3. Out here, 1/3. And we're evaluating this from what? From 0 to 3, no? Yes? Yes, yes. So, I'm going to go ahead and at the end do this 1/3 little thing that is kind of messing me, like it's just there. So what we're going to do is let's work out the inside of this thing. This 1/3 is for the whole quantity here. So I'm going to plug in 3. So this is going to be 3 to the third power over 3 plus 2 times 3. That's the evaluating at 3. This quantity. Okay. And then I'm going to minus when I evaluate 0 in for it. But it's just going to become 0 here. 0 to the 3 over 3 plus 2 times 0. Which this whole quantity is going to be 0, no? Because when you ever plug in 0 here, this whole thing is going to be 0 here. So now we just got to evaluate this inside here. So we're going to go here. So we got a 1/3 brackets. 3 to the third is 27 divided by 3 is what? 9? 9 plus 6 is it? And the other part, this whole thing is just 0 already. And 9 plus 6 is what? 15? What's a third of 15? So the height that we need that would fit it perfectly would be 5. Let's see. And it's going to fit it perfectly. This will come down here, and that these two are the same. Yeah? That's it. That's what the, let's do one more. Now you get the idea of what an average value is. Let's go. I think it's all right. It's pretty easy. It's just all you got to divide by the interval. So you integrate it, divide it by the interval. One over what? 1 over 2. Integral from what? 0 to 2. Integral from 0 to 2. 8x minus 3 plus 4e to the x. And we're integrating this. One half. What's the integral? First part.
4x squared.
Minus what? 3x. Plus what? 4e to the x, no? Evaluate it from 0 to 2. Yeah, you got to be careful with this because e to the x will not cancel out when you plug in 0, like in the other problem. That's what. So let's evaluate it. So this is going to be 1/2, 1/2, and let's plug in the 2. So we're going to plug in 4x is 2 squared minus 3, 2 For e to the x is 2. Okay. And then we're going to do the 0 part 1. So then we're going to minus. Well, this is going to become 0. That's going to be 0. That part, this is 0. And then plus 4 e to the 0. Parenthesis around here. Be more proper. All right. 2 squared 4. 16. It's just the algebra of it. 16 minus 6 plus 4e squared. Minus, that's gone. That's gone. Minus 4. What's e to the 0? So it's minus 4? Minus 4. Yes? And so it's going to be what? 1/2. 60 minus 6 is what? 10. 10 minus 4 is what? So it'll be 6 plus 4e squared. And now we can just simplify this, and the answer will be half of 6 is what? 3. Half of 4 is 2e squared. So the answer should be 3 plus 2e squared. Yeah, so it's going to be 3 plus 2e squared. All right, let's do one more. I don't know. I don't want to be writing too much, but probably that's not right to be doing this. Average value, AV, I guess. I'm just going to put AV just to get going. Is going to equal to the integral from 1/2 from 0 to 2 x squared we're going to use what kind of method to integrate? Substitution. So we got to choose, what do we got to let u be? Let u equal to what? It's always a higher power that you break it. So it's going to be what? The inside of it. X cubed plus 1 du. Du is going to be what? 3x squared dx. Yeah, let's go directly to that, no? Du is 3x squared dx. Well, don't we almost have it here? What is it that we have? See, we're going to have square root of u. Yes, square root of u. But then I have x squared dx. That's not what we... Well, I need to get rid of this 3, no? Yes, got it? So it's going to be like that. So let's go ahead and plug it in. So it's going to be what? 1/2, 0 to 2, square root of u. And we're gonna have du and 1/3. Du, I'm gonna put that 1/3 here. Is du over 3, which is 1/3. I'll put it here. Which I can take it out. It's 1/6. In a minute, we just take it. So, how do you integrate square root of u? Well, square root of u is the same as what? U to the 1/2. So how do you integrate u to the 1/2? It will be add, so it'll be plus 2 over 2 is going to be 2 over 2 is going to be 3/2 over what? 3/2, which is going to be 2/3 u to the 3/2. Yeah? I'm doing this all on the side over here when you integrate. So this is going to be, let's go with, let's see, did I do this correct? Everything. I'm going to take out the 1/3, no? So it's 1/6. 1/3 and 1/2 times 1/2 is 1/6. And we integrate the square root of u du, and I've done this right here, right here, right here. So it's going to be this. Okay? So the integral will be that. And so it's going to be, I'm already going to substitute in for u, x cubed plus 1. Let me not. Yeah, let's go. But hold on. And we still have this 2/3. There's 2/3 here. 2/3. U is this x cubed plus 1 to the 3/2. Evaluate it from 0 to 2. When you plug in z, no, it's not. Man, this is a lot. So we can cancel this out right here, because I don't want to be writing so much. So it'll be 2 goes into 6, 3, and then it's going to be 3 times 3 is 9, 1/9. It's going to be 1/9. This is going to be x cubed plus 1, and I put it back in there. 3/2. And to the 2 there. All right. And now let's go ahead and evaluate. Let's go over there and plug it in. So I simplified this a little more, and now we're going to plug it in. Let's plug it in, and we're going to go here. It's going to be 1/9. X is 2 to the 3rd plus 1 to the 3/2. Then this quantity then minus, well, for the other one, and then we're going to plug in minus 1/9. X is 0. And another parentheses plus 1 to the 3/2. All right. Algebra is the problem. We just, if this is a calculator one, you just plug it into a calculator and do all this. All right, let's do this. We're all together gonna do it right here. 2 to the 3rd. I'm gonna have to jump inside of here. 2 to the 3rd. 8. 8 plus 1. 9. Square root of 9. This is the square root. Square root of 9. Square root of 3. Okay? We're doing the square root. You guys understand? I don't want to be doing so much. Square root of 9 is 3. 3 to the 3rd. 27. 1/9 of 27. 1/9 of 27. So this part is 3. Yeah? And so now we're going to do here, this one is going to be, go away. No, not the whole thing go away. But this this thing. Yeah. Well, no. See. Here's another problem. Don't make this mistake. This is a quantity. Yeah. So that's going to be 0 plus 1 is 1. 1 to anything is 1. 1 times a minus a ninth. So this is term minus a ninth. 3 minus a ninth. That's what I'm doing. Yep. Yeah, it has to be. What's 3 minus a ninth? Because you could put this be 27. I could have left it 27 over 9, no? 27 over 9 is 3. So it'd be 26 over 9. Anyways, the problem is not the problem is knowing how to do the algebra, and this is what they do. Okay. This is what they do. We could have changed the bounds better. If we would have changed the bounds, it might have done this. We could have done this much easier. We'll go over this kind of way of doing it. Maybe we should talk about it right here and finish it. Let's actually do it. Let's do it. Let's talk about how to change the bounds. You saw how difficult it was with the algebra here. If we changed the bounds, maybe this would have been easier. This is what we're saying. Okay. So let's see. So we're here. Let u equal that. Where'd it go? Hold on. Let's go back and change the bounds. So it would have been 1/2 integral. We'll have integral from 0 to 2 x squared x cubed plus 1. So we said let u equal x cubed plus 1. du is 3x squared dx. Okay, so then we say here we're going to go to 1/2 from 0 to 2. Then we're going to have square root of u. Okay, square root of u. And then we're saying dx. So then we have x squared dx. So you have to divide by 3 here, and now we have x squared dx, du over 3, 1/3 du. All right, here's the problem. And we could have made it a lot easier by doing this. Let's change the bounds. We got to change the bounds. Actually, I shouldn't even put these numbers here. This is wrong. It is wrong. Because if I have this statement with these bounds, go for this. They have to change for these udus. So how do we change these bounds? Well, just plug in 0 in for here. X is 0. So if x is 0, 0 to a third, 0 plus 1. So this bottom bound becomes 1. And now we're not gonna go back to this. We're gonna jump into this world of use and change the bounds and stay in this world of use and not go back to the x world. All right, this is what I'm saying. What would it be for 2? If you plug in 2, what is it? 2 to a third is what? 8 plus 1 is? So now we can just work with this completely. So if you go into this world of use, change the bounds and never go back to the world of x's, which I did before. Let's see if it works. So the integral of this would be what? Let's go 1/2. Let's go step by step. U to the 1/2 du. So why don't I take this out already? We had done 1/6. Yes or no? 2 times 3 is 6. No, 1/6. And let's have it as u to the 1/2 du. Which if you this is 9. So this is gonna be what? Plus to integrate, we're gonna what? U to the what? 3/2. Yes, and that's gonna be over 3/2. Gonna be 2/3. No, 2/3 times we already have 1/6. And the bounds are from 1 to 9. Isn't this much easier? Because we're not working with x's now. Because we're in this world. So if we go here, this is gonna be what? It's still gonna be what? 1/9 here. 1/9. Plug in. Actually, this is much easier to work with, and this is better. Let's see. I'm making it more. It's 1/6. Hold on. Let me go step by step here. So this is gonna be 1/9, 1/9, u to the 3/2, and let's go step by step. Let's have that like that. Simplify it better because this is gonna be 1/9. This part is 1/9. And now let's go ahead and just plug in. So this is gonna be 1/9, 9 to the 3/2, minus, and just keep it to 1/9 here. U is 1 to the 3/2. So here we want it's much easier this way. What's the square root of 9? 3. 3 to the third. A 9 to 27 is 1 minus 1/9. It is. Yes or no? I think this is the way to do it. If you are going to go into the U worlds, make sure you change the bounds. Never go back to the X world. It's way more complicated the other way. Yeah. Whatever I have here, I did change the bounds here on this one. 26/9. We're gonna finish off with this. Let's go. That's a lot of writing to go. We're just gonna finish in the class. Let's see. Yeah, let's go ahead and write that down. Write it down. Let me go because I'm gonna stop the lesson already on the video. Let me go. Copy it down, and I'm just gonna go over it real quick. A 12,000 liter tank. 12,000 liter tank of water is filled to capacity. At T equal to 0, water begins to drain out of the tank at a rate modeled by that, measured in liters per hour, where R is given by the piecewise defined function. Find the average rate at which water is draining from the tank between time equal to 0 and time equal to 8. This is a calculator problem, I think. Yeah, it is a calculator. So let me show you the setup. Let's do the setup. Average rate equal. We're not going to do it because we need a calculator, I think. Maybe not. But I'm just going to give you the average rate. Average value is average rate. I'm using average rate as average value. It's the same thing. And it's going to be, because this is a piecewise function, we're going to have to go from what? First, it is this from 0 to 5. So it's going to be 1/5. The integral of this function because we're going from 0 to 8. And then that average, and I think we're going to have to add it to the other average. Two averages? Do you add those two averages? And divide those by 2? Because you got two averages. And this other one is going to be from 5 to 8. It's going to be 1/3. And it's going to be integral this dt. And then this is 1,000 e to the negative 0.2t dt. Because it's a piecewise function. This average plus that average, I'm almost thinking, get these two and divide it by 2. It's like the most common sense. But let's see what we got here. So this is the setup. This is my question. I don't know if the way I had it would be give you the same answer as this one. Yeah, that's a good question. We need a calculator to do it. If it would have turned out to be the same answer, the way I said it. The way I said it was, let me go back. I said it that it's 1/5 of this plus 1/3 of this. I don't know. Actually, I'm gonna stop I'm gonna put in a calculator. But we're done.